Hello everyone! Today I'll be discussing the CycloSal-Prodrug approach, an innovative strategy aimed at enhancing the properties of drugs. Throughout this presentation, we'll explore the concept of prodrugs, dive into the CycloSal-Prodrug approach, its various applications, and the hydrolysis mechanism involved. Let's dive in and explore this exciting topic. Let's start by understanding the concept of prodrugs. Prodrugs are inactive compounds that rely on metabolic conversion in the body to release their active form. This approach helps improve various drug properties such as metabolic stability, solubility, permeation, minimizing toxicity, improving patient compliance, and achieving site-specific delivery. Pro-moieties are commonly attached to the active form of the drug by chemical groups such as ester, carbamate, phosphate, ether, carbonate, amide, among others. Now let's shift our focus to one of the phosphate-based prodrug approaches, which is the CycloSal-based prodrug approach. The name CycloSal originates from its structure, which is a salicyl alcohol that is used as a cyclic bifunctional masking group for nucleoside analogs. The CycloSal prodrug approach has been applied to improve the properties of synthetic nucleoside mimetics, which are crucial for antiviral and anti-cancer treatments. It has been proven that when CycloSal is added to monophosphorylated nucleoside mimetics, it was able to 1. Improve cell penetration, 2. Prevent drug degradation, 3. Improve activity in resistant strains. To improve the effectiveness of nucleoside mimetics, they are often provided in their monophosphate form. However, this form is highly polar, which affects its ability to cross cell membranes, making it less effective. By masking the polar phosphate group using CycloSal per moiety, we are allowing the prodrug to cross cell membranes more efficiently. Once inside the cell, the active nucleotide is released. CycloSal prodrugs also prevent drug degradation by protecting nucleoside mimetics from enzymatic breakdown during the nucleoside stage. For example, DDA and D4A anti-HIV agents are prone to deamination by adenosine deaminase. CycloSal protects these drugs until they reach their target site, which was proven by the increased anti-HIV activity. In the case of antiviral drugs like acyclovir, viral resistance often involves mutations in thymidine kinase, the enzyme responsible for the first phosphorylation step in the activation of acyclovir. CycloSal derivatives bypass this step by delivering the monophosphorylated form directly, reducing dependence on thymidine kinase for activation. Chemical hydrolysis studies in different buffer solutions at different pH values prove that all prototype compounds released monophosphorylated nucleotides and salicyl alcohols in a pH-dependent manner. In the first step of hydrolysis, the phenolate is displaced preferentially at the phosphate group, leading to 2-hydroxybenzyl phosphate diester. Due to this initial cleavage, the remaining masking group is activated and a spontaneous breakdown of diester to the nucleotide and salicyl alcohol is induced. Although the first-generation cyclosal triesters showed promising antiviral activity, relying solely on chemical hydrolysis presents certain limitations. Since extracellular and intracellular environments have similar pH, hydrolysis can also occur extracellularly. Additionally, the lipophilic nature of cyclosal triesters may allow them to be exported from cells. To avoid efflux of CycloSal prodrugs, second-generation cyclosals were designed to have high lipophilicity so that first they are able to cross the membrane, but then they are able to be converted inside the cell into a more polar compound by an enzymatic reaction. This is known as lock-in or trapping mechanism. In conclusion, CycloSal-based prodrugs prove their ability to improve the antiviral activity of nucleoside analogs by improving penetration, avoiding degradation, and bypassing viral kinase activation. For more details, check out the following references. Thank you for watching. If you have any questions or want to dive deeper into the topic, feel free to reach out. See you next time!